Good morning, students. Today we start chapter number 8, remainder and factor theorems. So before start of the remainder and factor theorem, let us first understand some basic concepts. First of all, polynomial. Polynomial means an expression of the type which involve variable and few real numbers which are called the coefficients of the variable terms with different powers. So an expression of the following type like px is equal to a0 plus a1x plus a2x square and so on up to an xn, where all a0, a1, a2, an are real numbers and n is the highest power of x and x is a variable, is called polynomial of degree n in variable x. Degree means the highest power which occur in the expression. Here we consider a few examples. First example is px equal to 2x square minus 7x plus 5 is a polynomial of degree 2 because here the highest power involved is 2. Similarly, another example we can take px is equal to 7 minus 2x. It is again a polynomial of degree 1 because the highest power of the polynomial here is 1. The next basic point is value of polynomial at a point. By value of polynomial at any point, we mean that when we substitute the value of variable in the polynomial. Suppose px is a polynomial and a is any real number, then p of a is called value of the polynomial at that point. For example, if we consider px is equal to 2x square minus 7x plus 5, then the value of px at x equal to 2 is given by p of 2 is equal to 2 into 2 square minus 7 into 2 plus 5. What we had done? We replace x by the number 2. Now solve it. Simplify, we will get p of 2 is equal to minus 1. So therefore value of polynomial at a point x equal to 2 is minus 1. Now we shift to remainder theorem. Remainder theorem is the theorem related with polynomial. In this, we state this theorem as if fx is any polynomial of degree greater than or equal to 1 and it is divided by any linear polynomial x minus a. Linear polynomial means a polynomial having degree 1 and a is any real number. If we divide any polynomial with linear polynomial x minus a, then the remainder is given by f of a. So we can explain this theorem by means of a following illustration. Let fx is 5x cube minus 2x square plus x minus 1 is any polynomial and is divided by a linear polynomial x minus 2. Then the remainder is f of 2. How f of 2? Because according to remainder theorem, if a polynomial is divided by linear polynomial x minus a, then the remainder is given by f of a. So here a is equal to 2. So we can put the value of x equal to 2 in the given polynomial and solve it, then we get remainder as 33. We can verify this by the actual division also. If we divide the polynomial fx equal to 5x cube minus 2x square plus x minus 1 by x minus 2, you will get the same remainder, that is 33. The next theorem is factor theorem. Factor theorem is related with remainder theorem when a polynomial is said to be factor of another polynomial. When it is completely divisible by the given polynomial. Suppose we have two polynomials fx and gx, then gx is said to be factor of fx if fx is completely divisible by gx. So now factor theorem relates this thing for linear polynomial and any polynomial. Suppose fx is any polynomial of degree greater than or equal to 1 and a is any real number, then x minus a, linear polynomial, is factor of fx if and only if f of a is equal to 0. We know that f of a is the remainder when fx is divided by x minus a. And if remainder is 0, then it is factor. So x minus a is factor of fx if and only if f of a is equal to 0. Now here again you can see one illustration. If we consider fx equal to x cube minus 6x square plus 11x minus 6, and we check it for a equal to 1. If we substitute a equal to 1 here, the answer is 0. F of 1 is equal to 0. Then we can say that x minus 1 is a factor of fx. Similarly, same polynomial for another linear polynomial x plus 1. Now here, if we put x equal to minus 1 in fx, the answer is not equal to 0. So we can say that x plus 1 is not a factor of fx. Now we shift to the questions of exercise 8a. In first question, we have to check the remainder when fx is divided by x minus 1. So first of all, we will give the name to these polynomial. Fx is x power 4 minus 3x square plus 2x plus 1, and gx x minus 1. Now, in order to find a, we can put gx equal to 0, that is x minus 1 equal to 0. So it gives x equal to 1. So using remainder theorem, we can find the remainder by substituting the value x equal to 1 in fx and solving it. So f of 1 is 1, means when fx is divided by x minus 1, then the remainder is 1. Similarly, you can try for the first, second part and third part. In question number 2, we have to show that x minus 2 is a factor of 5x square plus 15x minus 50. We will proceed in the similar way as in question number 1. First of all, we put gx equal to 0 and get x equal to 2. Then we will find the value of fx at x equal to 2. It is 0. So we can say x minus 2 is a factor of fx. Now similarly, we can solve second part, third first part, third second part, and third part. Now, in some questions, we are given the condition that a linear polynomial is factor of another polynomial, and we have to find the value of some missing term. Like in the question number 4, if 2x plus 1 is a factor of 2x square plus ax minus 3, then find the value of a. So here fx is equal to 2x square plus ax minus 3, and gx is 2x plus 1. So we can put gx equal to 0 to get the value of x. X is minus half. As in the question, it is given that 2x plus 1 is a factor of fx. So it means f of minus half is equal to 0. So we will put minus half at the place of x in fx and solve it. After solving, we will get a is equal to 5, minus 5. So similarly, we can solve fourth, second part. Sometimes we will get two factors and have to find the two missing terms. As in question number 5, here x minus 2 and x plus 3 both are factors of the expression x cube plus ax square plus bx minus 12. So both are the factors. We will apply the same condition of factor theorem. For first x minus 2, x equal to 2, and for second x plus 3, x equal to minus 3. We will put both these values in fx and equate it equal to 0 to get equation number 1 and 2. First equation is 2a plus b equal to 2, and second equation is 3a minus b is equal to 13. Now we will solve these two linear equations in two variable by elimination method. Add these two equations. We get 5a is equal to 15. So a is equal to 3, and by substituting the value of a in any, we will get the value of b. b is equal to minus 4. Similarly, we can solve question number 9, question number 14, and and the rest of the question of the exercise. So you have to complete this exercise 8a. Then there is another method. By using factor and remainder theorem, we can factorize a given cubic polynomial. So in order to factorize, we will use the following steps. So I am going to explain these steps. First of all, we have to find the factors of constant term in the given polynomial. And then for each factor, we have to check the value of polynomial at the factor where the value of polynomial is 0. We will stop. And then by using factor theorem, we can say that x minus that factor is a factor of fx. and then we will divide fx by that linear polynomial to obtain a quadratic polynomial. Then we can factorize that quadratic polynomial using algebraic identity or by splitting its middle term to obtain all the factors. So let us understand this thing by question number 2 of exercise 8b. Question number 2, first part. He said using remainder theorem, factorize each of the following completely. So we will take first part. Here the fx is 3x cube plus 2x square minus 19x plus 6. So the constant term is 6. We will find all the possible factors of 6. It is plus minus 1, plus minus 2, plus minus 3, plus minus 6. We will consider both the signs, plus as well as minus. Remember one thing, that number and 1 both with positive and negative sign is always a factor. So we will check the value of polynomial at 1, it is minus 8, not equal to 0. Minus 1, 24, again it is not equal to 0. At 2, it becomes 0. So we will stop here. So therefore, when fx is divided by x minus 2, the remainder is 0. It is by using remainder theorem. And we know that if remainder is 0, then x minus 2 is a factor of fx. So now we divide fx by x minus 2. You know the method of long division. We make the first term of the dividend equal by multiplying some term with the divisor. So first we multiply the divisor by 3x square, then 8x and then minus 3, and we will get remainder 0. So fx can be written as divisor into quotient. Divisor is x minus 2 and quotient is 3x square plus 8x minus 3. So now we will consider quotient separately and give it the name f1x. Now we can split the middle term. Middle term can be split as 9x minus x, because 9 into minus 1 is minus 9. It is same as 3 into minus 3. That is coefficient of x square and constant term. Now combine first and second term and third and fourth term. From first and second term, take 3x common. It is x plus 3. From third and fourth term, take minus 1 common. Again we get x plus 3. Now x plus 3 can be taken common. So it is x plus 3 into 3x minus 1. If we put the value of f1x in 1, we will get all the factors of fx, and answer is written as fx is equal to x minus 2 into x plus 3 into 3x minus 1. Sometimes they said solve the equation, cubic equation. So similarly we will obtain the factors and then equate it equal to the 0. And we know the product of terms is equal to 0 if any of the term is 0. If 3 factors, the product is 0, then any one of them must be 0. So it may be x plus 1 equal to 0, it may be x plus 3 equal to 0, or it may be 3x minus 2 equal to 0. So we will get the solution of the equation 3x square plus 10x square plus x minus 6 equal to 0 as minus 1, minus 3 and 2 by 3. If we take question number first, here already one factor is given. We have to show that this is the factor of given polynomial. So here we can apply factor theorem. We can take gx as x minus 2 and then put it equal to 0 to get x equal to 2. And f of 2 comes out to be 0. So we can say x minus 2 is a factor of fx, and rest by dividing fx by x minus 2. We will get other factors. Now here quotient is x square minus 9. So here we can use identity a square minus b square equal to a minus b into a plus b. So fx ultimately written as x minus 2 into x minus 3 into x plus 3. And some complicated or typical type of questions are also there, which we can prove using factor theorem. If we consider question number 7, in question number 7, it is given that x plus a is a common factor of the expression fx x square plus px plus q and gx x square plus mx plus n. We need to show that a is equal to n minus p over m minus p. So we know that if any linear polynomial x plus a is a factor, then by putting x plus a equal to 0, we get x equal to minus a So it means g of minus a and f of minus a both are 0. So it means they are equal. So we can put f of minus a equal to g of minus a. By substituting the value of x equal to minus a in both the expressions, simplifying, we will get the desired result. First, a square cancel from both sides. Then we can shift ma from right hand side to left hand side. It becomes positive. Q from left hand side to right hand side, it becomes negative. Then take a common from left hand side. It becomes a into m minus p is equal to n minus q. So a is equal to n minus p over m minus p. So we can prove the result using factor theorem in this way. So thank you students, and soon you will get the written of this.